Hi, I am Debbie Dawson-Gunther. I'm a faculty member here at Montcalm Community College in automation and in advanced industrial technology. And what I want to share with you today is our automation program. So our automation program has two separate paths that you can follow. One of them is a one-year certificate, and then the second one is our two-year associate's degree. So with our one-year certificate, you are going to be able to go into industry. It could be a new position. It could be an entry-level position. It could also be taking you from where you're currently working into a new field. And what we cover, and we start this with our program. So you'll start with electrical. You're going to understand the fundamentals of electricity. You're going to start to see what some of our components look like. You're going to see the difference between AC and DC electricity. And then you're going to start to put these together and understand how they work. So that's really how we get you started in our classes. I will share with you that we use math. So a lot of you might cringe, but we use, and we do this in all of our industrial programs, we use applied math. So it's not the memorizing formulas. It's how am I going to take what I'm measuring, because we have tools you're going to learn how to measure electricity with. How do I take those measurements and use them for something else? Can I use them to troubleshoot? Can I use them to solve a problem? Can I use those to fix what I need to fix in my job? So it is math, but it's not scary, and it is applied math. So that is something that's part of our program that I do want to let you know about, but we make it fun and we have a good time with it and give you a skill that you can take into the workplace. So another topic that we cover when we're in our class, one of our fundamentals of electricity, is control logic. So we take everything that we learned with our components, and now we're going to figure out how to do something with that. So we're going to, more than turn on a light or make a fan run, we're actually going to control solenoids. We're going to take signals from limit switches, and we're going to make all of that work together. You're going to draw control diagrams so that you can start to see what the documentation would look like in the workplace and be able to follow it through so that you can do some troubleshooting with that. So this would be the second half of our first class that you would be able to apply electricity to. So the next class that you would take from the automation track would be our motor controls. So we learned a little bit about it before. We understood what electricity did. Now we're going to put some high voltage components together. So we're going to be working with larger motors. And when we do that, we want to make sure that you're staying safe. The other trainers that we've looked at, those are lower voltage. We're not as concerned about those as safety-wise, although you have safe practices you have to say to maintain. But when we're running with the higher voltages and our motors, we have a lockout tagout procedure, and this is something that you would see in industry. So it's nothing different. So you'll be prepared when you go into the workforce to know that if you see this, you know someone's working on it. So the lockout tagout procedures we use, and then we have our trainer with, again, the components that you would see out in industry, and we're controlling motors. We're going to put together some of our control diagrams so that we can look at how we can do different things with our motors. We can make them run forward, backward, figure out how they're going to run those production lines. And with the information that you have from this class, you'll be able to do another level of troubleshooting out in the workplace. So all of the trainers that we have here in our lab, you would come in person and work on those. The beauty of these trainers, though, is that we have the ability to connect them to the simulators. So you can actually practice your skills, work on any of your control diagrams, work on any of your problem solving. You can do that any place you have an internet connection. So we do have simulators that we can use for each of the three trainers that I've shown you already. So this is our PLC trainer. PLC stands for Programmable Logic Controller. And with this skill, you'll be able to control production lines. So the lab that I showed you before had components that you had to physically wire. Every time you move them, you would have to move all the wiring that would go along with it. So if you're out in the workplace and they decide to move a production line from, north-south facing, say, and they want to turn it 90 degrees, all of the wires that are connecting those components would have to go with that. So it's a significant job to move something around in a plant. With PLCs, we only wire those to our controller here. This is like a mini computer that we have. So all of our wiring comes into a central place, and we can control everything that happens in the plant from one location, from our PLC. So we don't have to spend a lot of time rewiring a plant. We can control it all from here. We can move it. We can change it however we want. What you'll learn here is how to create programs where you will be able to take signals that are coming in, very similar to what we saw before, the switches, the push buttons, the start buttons that we have here, and control something. So we have fans, we have motors, we actually have a mini production line here. So this is a conveyor system, and you will write programs that use all these components so that you can figure out how those would work in a production line in a real world setting. So our courses are aligned with what industry is looking for. So we use SACA credentials, Smart Automation Certification Alliance is what that stands for. And what that means is industry has gone and said, this is what we need. This is what we need our employees to know. So once you go through our classes, you'll be able to take those exams, and you can prove to the employer, they can look at your resume and they will know what level of skill you have earned and that you already understand. Once you go through the courses that are part of our certificate program, you can complete your associate's degree. And that second half of your education, that second year, will be mainly based on robotics. So you have the PLC, you have the fundamental knowledge, you have the math that we're using, and now we're going to apply it to robots. So we start off with some of the smaller ones. So these are our tabletop sized robots. They do the same functions as our larger robots do, but it's more manageable, and it's something that you can use and see and figure out how you can determine how that robot moves. So you'll be able to learn all about the robot, the programming, and where it is in space. And again, these are the ones that are used in industry, so it's pretty cool to be able to walk away with a skill that's definitely in demand. So once you've had a chance to work with the tabletop robots and understand how they work and how they move, you'll get a chance to practice on a large industrial sized robot. So you're able to take those same principles and concepts that you learned on a smaller tabletop and apply it to our large industrial sized robot. With the larger industrial robot, you'll also be able to do troubleshooting. You'll take it apart, you'll put it back together. You'll be able to see how the maintenance is done in the real world, so that when you go to your job, to your workplace, that is a skill that you can take with you, and it's definitely something that's in demand.